Okay, so today's lesson is going to be on linear relations once again, except this time around, we're going to focus on how to represent linear relations algebraically. In other words, we're going to be focusing in on how to write a formula that actually represents what a linear relation is talking about. So in other words, however much one variable is going up as the other one goes up as well, or goes down, whatever. Same idea. Anyway, let's get rolling. So today's plan, we're going to continue learning about linear relations today, this time focusing on representing linear equations algebraically, so in other words, as an equation. This is in the form y equals mx plus b. So we're really going to hone in on what those letters represent, how to find them, and how to stick it all together as a linear equation. In other words, an algebraic representation. First of all, though, we'll talk about how to turn a graph into an equation. Turning a graph into an equation is arguably much easier than the other ways. Then we'll talk about how to turn a table into an equation. That I would certainly say is a lot trickier. And then the last one, how to turn written information into an equation. Yet again, the trickiest thing yet. I'll follow or try to follow along really carefully as I go through this. I'll try to take as much time as I can explaining this. If you feel confident in how to do something, maybe you could even pause the video, try it on your own, and then see if you get it right. But other than that, here we go. So first, let's recall linear relations from last class. We discussed that a linear relation is a relationship between two different quantities, in other words, variables, in which as one quantity goes up by one, the other one goes up by a set amount each time that doesn't change. We looked at linear relations as tables and as graphs yesterday. We also looked at how to calculate the slope of a linear relation. The slope of a linear relation, especially if you had a graph, was just your rise over your run. So we saw this graph yesterday talking about plant growth in terms of height over days. If you were to look for the slope, it's just the rise of that. So in other words, how much you go up by, that would be our rise divided by how much we run over by. So rise over run. All of this will be important for today. We do need to know how to find slope, regardless of whether we had a graph or a table. But I will review it as we go through this as well, so don't worry. The focus for today will instead be to look at linear relations as an algebraic statement. In other words, a mathematical expression. Here we go. So when a linear relation is expressed algebraically, it will take the following form: y equals mx plus b. Let's focus on what each of those four letters mean. Y, of course, well, that's just the value of your dependent variable. That's your y value, right? Not really a big surprise. X, I'm skipping m for a second here. X represents the value of your independent variable. That's the thing you're actually plugging in. So you get to choose what X to plug in, and then whatever M and B, that's going to change what's happening to X, and it's going to spit out a Y. That's the whole idea here. Now, M and B are the ones that are arguably the most important here for today. M is the value of your slope. Now, don't ask me why they use M to represent slope. I actually have no clue at all. I always thought M just would represent like how much you're going up by each time or how much you're going down by, because you can have a negative slope as well. But M is just the value of your slope. So if you find your rise over your run, that's your M value right there. As for B, B is a really funny one. B is your y-intercept. In other words, this is the point on the y-axis that your line crosses. So if you have a graph and your graph looks something like this, we'll say, that was kind of messy. Whatever the value, like again, if this is your x-axis and this is your y-axis, whatever the value is right here of your y-intercept, that is going to be your B value. So you just have to look there. If you have a graph, bingo, bango, bongo, you got your y-intercept, and therefore you also got your B value. You're good, right? Now, when you are asked to write a linear equation, in other words, when you're asked to write these algebraically, your x and your y and your x will just remain as variables in the algebraic form. So in other words, you are really just going to be looking for an M and a B. So you might end up having an answer of something like y equals 2x plus 5. Boom, right there. That would be an answer right there. You do not put in an x and a y. You leave them as x and y, because the whole point of this is you want to be able to get some sort of expression where you can just pick it up and say, oh, I happen to know x is 10. Plug that in here. 2 times 10 plus 5, well, it'd be y is 25, right? You just want something so you can plug in whatever x you want, and it'll spit out whatever the y is corresponding with that x. So our objective today will be converting a table or a graph to an algebraic expression in this form. You just need two things. You need your slope, which is your M, and you need your y-intercept, which is your B. Let's start with a graph. So going from graphs to an algebraic form, relatively simple. You just need to do these couple steps here. Step number one is find the y-intercept. So again, if this is your graph and your graph is going along like this, your y-intercept is this right here. That's going to be your b value. Believe it or not, once you have that, you're literally already halfway done. Step two, calculate the slope using rise over run. Remember, as long as it's a linear equation, so as long as it's a straight line, you can just choose whatever 2 points you know, right? It doesn't matter. You choose any 2 points. You can choose like a point here and a point here. Boom, there's your rise. Boom, there's your run, right? It doesn't matter. If you didn't want to pick those 2 points, it's not the end of the world. You could have picked other 2 points. I could have picked a point over here and said, you know what? We'll use this point and this point over here. There's our rise and there's our run. It should be the same amount. When you go rise divided by run, it should always be the same. Anyway, whatever that value is, rise divided by run, that's going to be your value of your m. Then, now that you have your b and your m, just write out y equals mx plus b. Leave y and x alone. Just leave them in there. They just stay as y and x. Literally, they just stay y and x. And then you're done. That's it. So to use it, just plug in whatever value of x you're interested in and see what y it spits out. That's the whole fun of this. Yay, you're having fun, right? I'm having fun. Here we go. Let's move on. So create an algebraic equation representing the following linear relation. We're back to this graph again. Probably because it was a pretty good one, actually. I just found it on Google. I'm not going to lie. So it's the plant growth one again. If we're going to make this into a linear equation, or an algebraic equation is another way of saying it, we want y equals mx plus b. So our job is to find our m and find our b. I always start by finding b. I think b is the easiest thing to find here. B is just your y-intercept. Well, look at our graph. This is our y-axis right here. Look at this. This is our y-intercept. It's right between 0 and 2. I wonder what number lies right in between 0 and 2. Of course, b is equal to 1. Look at that. We're halfway done. We already have one of these 2 things. Awesome. Now, next thing we have to find is m. You might actually remember what m was from last day. If you did, haha. If you don't, oh well, not the end of the world. To find m, just pick 2 points. I usually like picking the first point and the last point. You know, I'm going to change things up right now. I'm looking to make things a little spicy here. I'm going to choose this point. No, you know what? I'm going to make things really spicy. I'm going to choose this point. And how about this point? Just to really illustrate, it doesn't matter what points you pick. You can use whatever points you want. So if I'm picking these 2 points, I want to find my slope, so my rise over run. I'm going to go up this way. This is my rise. Let's see how far I went there. I went from 4 to 7, I guess. 4 to 7, that's a rise of 3. And then I'm going to run this way. So I went from, it looks like I'm going from 3 to 6. Yeah, 3 to 6. So 3 to 6, that's a run of 3. So this is my rise. This is my run. So rise divided by run. You probably already have this. Rise divided by run is 3 divided by 3. Well, that's kind of a coincidence. 3 divided by 3 is also 1. So 1 is my m value. It's pretty rare that both those numbers are the same, but it is what it is. Anyway, last step, we actually have to write this as y equals mx plus b. So we know m is 1 and we know b is 1. So I'm just going to write this as y equals 1x plus 1. That's it. Now, since there's an x here, you don't actually have to write 1x. If you really wanted to, you could say y equals x plus 1, because that means the exact same thing. But either of those work. I'd say both of those are right. It's up to you, however you want to do it. So long story short, when you have a graph, just find your y-intercept, that's your b, and then find your slope, that's your m, and you're done. Just write it as y equals mx plus b. Awesome. All right, what about this one here? Create an algebraic equation representing the following linear relation. Okay, so this time around, once again, we have a graph. We want it to look like this, y equals mx plus b. Start by finding your b value. Your b value is your y-intercept. This one's really funny. Notice where we're crossing our y-axis. This is our x-axis here, and this is our y. We're actually crossing our y-axis right at 0. So b is equal to 0. That's like how high it is on the y-axis here. So b is 0. That's all we can say there. That's interesting. Now, as for our m, remember m is just rise over run. This one's a little bit more suspicious. Matter of fact, I think this one's quite strange. It's Katrina's earnings over time. It almost looks like this one's a bit of a guessing game, actually. I don't think we really have a very good grasp of this. If I were to estimate this, though, let me actually just see. I was going to say I'm not finding a really good perfect point to pick here. Well, you know, I think we just have to kind of estimate this one, unless this is 25 and this is there. You know what? I'm just going to estimate this. What I'm going to say is, and just in case you're having a hard time understanding why I'm kind of humming and hawing on this one, what's kind of interesting about this one is there's not really a definite point here, because this one up here, this looks like a definite point. Like it looks like it's at 4 hours and $50, but it actually looks like it might be a little bit above it. I'm going to pretend I didn't see that. I'm going to pretend that instead this one right here is right in between 20 and 30. So I'm going to pretend that's right at $25, just for the sake of making our life easier here. If we're pretending that that one's right at $25, if I'm using these 2 points I put in here, my rise from 0 to 25, so rise over run, my rise from 25 or from 0 to 25 is 25. And then my run along this way from 0 to 2, remember we're using our scale here. So from 0 to 2, my run would be 2. So 25 divided by 2, well, that's 12.50. Cool, right? So that's going to be my M value. So to finish this off, we would say y equals 12.50 x plus 0. But that plus 0 does nothing at all. So you know what, I'll make this even better. Y equals 12.50 x. Done. That right there, that's my algebraic equation representing this linear relation. So it's a little bit unfortunate. Again, this one kind of threw me off. I was hoping that'd be a little nicer. Believe me, any of the ones that I'll give you, they'll be a lot more clear than this one. This one was, I'm not really sure where this one came from. But hey, you get the idea. At least I hope you do. But we'll see. Anyway, moving on. Now, one other thing I got to say is the difference between a direct and a partial linear relation. I think I mentioned this last class what a direct linear relation is. That last example we just did was known as a direct linear relation because it passed through the point 0, 0. Since it passed through there, it's direct. That's just what we call it. So I want you to note that it didn't have a b value, or rather b was equal to 0, right? So in other words, it was direct. There was no plus nothing, right? You don't worry about that. If a linear relation isn't direct, we call it a partial linear relation. This isn't really a big deal because they're still linear relations regardless of whether or not they're direct or partial. But this is just a distinguished thing that we put into Math 30-3 for who knows what reason. It's just something you got to know, right? So the plant growth one, that one was a partial linear relation because it didn't pass through the point 0, 0. Or in other words, it had a plus b. In this case, it was a plus 1. Anyway, moving on. Now, next one. We've talked about going from a graph to an algebraic form. And this one's a little beefier. We're going to go from a table to an algebraic form. So this is a bit trickier. We want to, we still want to get y equals mx plus b, but here's some tips. There's not really like a first do this, then do this thing. You're going to need some tips on this one. The first tip is the value of b is still your y-intercept. It's still where you're crossing your y-axis. But you got to keep in mind on a graph, oh, that was miserable. Let's try that again. On a graph like this, where you're crossing your y-axis, while it's nice that we can see it visually, what's really happening is that's where x is equal to 0. Because remember, our x-axis this way, x is equal to 0 right there. So on a table, if you can see where x is equal to 0 and then find the corresponding y value to that, that value is going to be your b, right? So if you can find where y or what y is when x is 0, that's going to be your b. Now here's the trouble. Sometimes your table doesn't have that on there. Sometimes your table doesn't even contain x is 0. This unfortunately means you might have to extend your table. In other words, you might have to work backwards to do this. I guess another way to find this, like sometimes b is really an unknown. Sometimes by looking at your table, you'll know what your slope is, and then you'll be able to like work backwards using just your slope, using your m. But it is what it is, right? Anyway, we haven't even talked about slope yet, so let's get into that. So the value of m, again, is still your slope. This isn't as easy to see on a table. As a matter of fact, instead of using rise over run, you probably want to consider slope to be this little more complicated formula here. What this formula says is it says your slope m is y2 minus y1 divided by x2 minus x1. So just to be a little bit more clear on what this means, if you had your table x and y, and then let's say it was like 1, 2, 3, 4, and then this was like, I don't know, like 3, 6, 9, 12. If you wanted to find your slope, I mean, this one's pretty clear. You're going up by 3 each time. Boom, there's your slope. But if you really wanted to find your slope on this one, just pick a y2 and a y1 and an x2 and an x1. So if we say this is 0.1, and we'll say this one is 0.2, I just skipped one just for fun here, then that means this is our y2, and this is our x2, and this is our y1, and this is our x1. So in other words, you can go y2 minus y1, so you can go 9 minus 3, divided by, you can go x2, which is 3, minus x1, which is 1. And of course, 9 minus 3 is 6, 3 minus 1 is 2, 6 divided by 2 is 3. Just like I said, we knew we were going up by 3 each time. But still, this formula can be super powerful, super useful. And you don't have to memorize it. You get a formula sheet in this course. It's right on there. It's top left-hand corner. It's on there. You don't have to worry about it. It even says, I think it even calls it slope on there. Maybe I'm wrong. Maybe it doesn't call it slope. It definitely says this though. M equals blah, blah, blah. Here we go. So I'm going to give us a whole bunch of questions with tables. We're just going to go through them. If you really want to like pause and try them on your own, that might be a good idea, but it's up to you entirely. Create an algebraic expression representing the following linear relation. Pretty plain, boring old table here. So if you want to pause the video, give it a try, go for it. But aside from that, let me go over it. So remember, we want y equals mx plus b. Now, b is your y-intercept. Your y-intercept happens when x is equal to 0. Take a look at our table. Here, there's x is 0. What is y? Oh, y is 1. Wow, so that actually makes it nice. When x is 0, y is 1. That means that's our y-intercept. So in other words, b equals 1. There we go. We're halfway there. We already got our b value. Now, m is our slope. That just means how much we go up by each time. This table is kind of funny because it goes 0, 1, 2, and then it skips 3 for some reason and goes 4, 5. Well, I mean, you could easily fill 3 in. If you put a 3 in here, you're probably noticing 1 to 4 went up by 3. 4 to 7 went up by 3. 7 to 13 went up a lot, but 7 plus 3 is 10. So at 3, we're at 10, and then plus another 3, we're at 13. Whew, okay, it's a linear relation. It kept going, right? So m in this case, m is 3, because that's how much our y is going up by every time x goes up by 1. Really important to clarify on that. That's only working here because x is going up by 1. If we didn't have x going up by 1, we'd have to use that more complicated formula, the one that says m equals y2 minus y1 over x2 minus x1. So if x wasn't going up by the same amount each time, you would have to use this because it wouldn't be as clear. Just for fun, I'm going to use that formula anyway, just to show you how it works again. How about I pick 2 points? How about I say this is my point 1, and just for fun, let's say this one's my point 2. So that means this is my x1, y1. We'll call this my x2, y2. This is totally unnecessary, but again, I'm just showing you. Y2 minus y1, that'll be 16 minus 1 over x2 minus x1, so over 5 minus 1. Oh, sorry, not minus 1. Sorry, that's minus 0. Sorry, x1 was 0. Anyway, this gives us m equals 15 divided by 5. Big surprise here. 15 divided by 5 is 3. So again, totally unnecessary because we could see it. But again, this formula, super powerful, really, really useful, especially for solving these things. Anyway, we found m is 3 and b is 1. So guess what? We can write this out. Y equals 3x plus 1. Awesome. All right, here's another one. So once again, let's make a formula, except this time for this table. You might want to pause the video here and give this one a try. Up to you. All right, so once again, y equals mx plus b. This question was also very nice. It told us x is 0 and told us what y was when x is 0. That's our y-intercept. In other words, that's our b value. So b, in this case, is 6. Well, that was quite a weird 6. Oh, well, you get the idea. B is 6. Now, m, how much are we going up by each time? Well, that's a bit of a trick question. Every time x goes up by 1, y is actually going down from 6 to 1. It's going down by 5. Right? So we minus 5 here, and then 1 to negative 4, we went down by 5 again, down by 5 again. Awesome. Now I can use this trick because I can see x is going up by 1 each time. If x was going up by something weird like 25 or something, we wouldn't be able to use this trick. That wouldn't be our true slope. You'd have to use that big formula. I'll spare us the trouble using that big formula again because I think you guys are probably already sick and tired of this. I'm sick and tired of myself doing it, so I imagine you can be too. But anyway, I can see clearly that m is negative 5. So since m is negative 5 and b is 6, y equals negative 5x plus 6. Done, right? Cool thing about this one is your slope is negative, right? So if you were to graph this, it would actually be going down. It looks something like this, where this is 6 and our slope, our rise over run, is negative 5. Anyway, moving on. Next one. Woo, look at the color on that table. Woo, geez Louise. All right, anyway, here we go. So create an algebraic representation, or expression rather, representing the following linear relation. Give it a try if you wish. Otherwise, we're going to go over it right about now. So once again, I always like starting y equals mx plus b. Reminds me what I'm doing, right? Now this one's a bit of a trouble. We don't have x as 0 on this chart. Uh-oh, right? That's not so good. Now you got some options here. You can work backwards on this. Like you can note the pattern that you got, work backwards, and then figure out what y would be when x is 0. I can show you what I mean by that. So notice from 4 to 6, that's a jump of 2. We go up from 36 to 56. That's a jump of 20. So if I'm going to go down by 2, I'm going to have to drop this down by 20. So this is going to have to drop down to 16. Now I want to go down 2 again to get to x is 0. So I got a minus 20 away from 16 again. That's going to give me -4. So there we are. B is -4. B is -4. So again, I just worked backwards. I noticed when I went up by 2, this one went up by 20. So if I go down by 2, this one has to go down by 20. And then I have to go down by 2 again to get to 0. So down by another 20. Another thing you could have done is found the slope, but I need the slope to do that. So I'll show you that in a second. Let's find the slope next. You probably can figure out how much y is going up by every time x goes up by 1. But if you can't, this is a really good opportunity for us to use that more chunky formula. So again, that chunky formula says m equals y2 minus y1 over x2 minus x1. It doesn't matter which one you call your first point and your second point, just as long as you're consistent with it. How about I say that this is my first point, and I'll just pretend this one's my second point. Again, it doesn't really matter as long as you're increasing from your first point to your second point. So if this is my first point, this is my second one, that tells me this is x1, this is y1, this is x2, this is y2. So if I throw this into the formula, y2 is 86 minus y1 is 36 divided by x2 is 9 minus x1 is 4. Well, 86 minus 36, I'm pretty sure that's 50. 9 minus 4, I'm pretty sure that's 5. 50 divided by 5, well, that's just 10. So we know m is 10. So with the information we got, we already have enough information to finish the question off. Y is equal to 10, that's our m, 10x, and then plus b, so plus -4. Why don't we just say that's -4? You can call it plus -4, that's just fine. But plus negative is just kind of awkward to me, so I just say it's -4. There it is. That one's done. Now, I alluded earlier to saying, oh, there was another way to find b. Here's how you could do it. Notice when we found m, we didn't care about the way we found b. We just used like x1, y1, x2, y2. We were able to find m on its own. I don't usually find m first, but there's nothing stopping us from doing that, right? Let's suppose we found m first, and we knew m was 10. Let's also suppose for a second we didn't know what on earth b was. Therefore, we could have just said, all right, we know we have y equals 10x plus b for whatever that is. We don't know what b is yet. We'll pretend we didn't actually find out it was -4. Let's just say we knew it's 10x plus b, and we're still looking for b. Well, here's something cool. We know a whole bunch of x's and y's. We get like a whole bunch of them. We got like 5 of each, right? Why don't you just pick one and throw it in, right? Now, it's going to involve a little bit of algebra, and if you're uncomfortable with that, then I wouldn't recommend it. But here's what I mean. Let's suppose we use just this one, just the first one I'm looking at, 6 and 56. So we know x is 6, y is 56. Why don't you plug those in there? So we'll say 56, that's our y, equals 10 times 6 plus b. Well, then that means 56 equals 10 times 6 is 60 plus b. We want to get b all by itself, but there's like a plus 60 here. So why don't we minus 60 from both sides? Boom, boom, that's now gone. 56 minus 60, bust out your calculator, you're going to see that that's -4. So -4 equals b. Holy smokes, we found b another way, right? This method right here, where I just take the m I know, and then I don't know what b is, I call that a skeleton equation. You don't have to do that if you're not comfortable with that. You don't have to, but I find that's a really powerful way of doing it, especially if we had like if we started here, if I hadn't given you anything back here, working backwards might take a long time. So this is where that one becomes a little more useful. But again, it's up to you entirely. All right, so we have a few more questions. This is a longer lesson than I thought it would be, but that's fine. We don't have to take forever on this, or you can split the lesson in 2. It's whatever, right? Anyway, so second example, or first word example today, I should really say. To celebrate your high school graduation, you book an entire restaurant for you and your friends. The restaurant charges a flat rate of $150 plus $15 for each guest. Create a linear equation representing this and solve for the cost of booking the restaurant with 30 guests. Interesting. So I'm going to give you a big hint here. This whole for each business, anytime you see like for each or per guest or something like that, you know you're going to be multiplying. You're going to be multiplying that there, right? Now, in a linear equation, we know linear equations always look like y equals mx plus b. The only multiplying going on here is right here in this m times x, right? So guess what? Since the fact every time you get another guest, you have to add another $15 to this, we can pretty safely say that 15 is our m. So why don't we say x represents the number of guests we have? I'll even write that over here. X equals the number of guests that we have. then why don't we say that y equals the cost, right? So since we know for each guest, we're charging $15, and then we have a flat fee or flat rate rather of 150 bucks, which means it doesn't depend on how many guests you have. We can just stitch this all together and say y, your total cost, equals $15 times the number of guests, so 15x, plus that flat rate of 150 bucks. So when you see a flat rate, that's just all by itself. And then when you see for each, you know that's what's multiplying whatever your x is, right? So our x in this case must be our number of guests, and our y must be our total cost. So this right here is our linear equation. That's half the question done. Now we want to figure out what it would cost to have 30 guests. Well, x represents the number of guests, so we know we have 30 guests here, so let's just plug in 30. So y equals 15 times 30 plus 150. Throw that in your calculator or even do bed mass on that. 15 times 30, that's 450. So y equals 450 plus 150. Add those together, 450 plus 150, that's 600. And I'm going to call that $600 just because it's asking for a money amount there, right? Cool, 600 bucks. That's what it would cost to book the restaurant. That actually seems pretty nice. All right, next question builds off the same one. So a different restaurant offered a different rate. You remember them saying they charge only $12 per guest. So, hey, that's actually nicer. They're charging less money per guest, but they had a different flat rate. You can't remember what that flat rate was, but you remember that they said the cost for 30 guests would be $695. Find that rate using linear relations. Okay, so remember last time, I'll even flip back to the last question. Remember last time our flat rate was our B value, right? That's going to be the same thing here, right? So since our flat rates are B value, we don't know what B is. So that's really our big question here. B is unknown right now. We still have 30 guests. So this is our X. And we know our total cost is 695. So that's going to be our value of Y. And we know what we're charging per guest, which last time it was $15. And that serves the purpose of being our M. So guess what? If we have Y equals MX plus B, we know what Y is. It's 695. We know what M is. It's 12. We know what X is, it's 30, so 12 times 30, and then B is what we're trying to find here. So like it or not, unfortunately, we're gonna have a little bit of algebra we gotta do in this one. So let's throw these numbers all in here, right? So we're gonna go 12 times 30 first, just to clean that up, because that's really gross looking at that there. So 695 equals 12 times 30 is 360 plus B. Now, if we wanna find out what B is, we just have to take away the 360 from both sides. So 360 away from both sides. The other side, a little bit of math here. 695 minus 360. Well, that gives us B equals a whopping $335. So holy smokes, compare that to the other restaurant. Let me just flip back for a second. Yeah, the other one was only charging $150 as a flat rate. So these guys, they're hosing you right there. Oh my goodness, right? So they're charging you twice as much. But cool, right? So in other words, linear equations that can be solved for a lot of, or used for a lot of really interesting things, right? Maybe I'm not selling this to you as well as it could be. Well, we got one last example. It's a three-parter though. Here we go. So the tree between McDonald's and Humpty's in Lethbridge was planted in 1984. This is the best tree in that city, believe me. This tree grows at a linear rate. In other words, it grows at the same amount every single year. Now in 2017, the tree was 550 centimeters tall. But then in 2022, the tree was 575 centimeters tall. So first part of this question says, find how much this tree grows per year. What does this represent in an algebraic statement? Okay, so we don't have a lot of data on this tree here. We know what its height was in 2017, and we know what its height was in 2022. So here's the thing, 2017 to 2022, that's 5 years. Now, just so you're aware, if we are talking about time, generally speaking, is our x-axis, right? In other words, it's our independent variable. It's something that we can like plug in. We're saying what year, and then the responding, or in other words, dependent variable is the height, right? So since time is our x-axis, and we went over 5 years, we can say our run, hint, hint, our run is 5 years. Now, the amount that the tree grew in that time, it went from 550 centimeters to 575 centimeters. So height in this case must be our y-axis. And since it's our y-axis and we went from 550 to 575, that certainly rose a bit, haha, right? So our rise is the difference between these two. Well, 550 to 575, you just subtract those two and you're going to see that our rise here was 25 centimeters. So if we rose 25 centimeters in 5 years, the rise over run will be 25. That's our rise over our run, which is 5. 25 divided by 5, well, that's going to be 5. And that would be centimeters, because this was centimeters on the top and this was years on the bottom. So it'd be centimeters per year. 5 centimeters per year. That's how much this legendary tree grows by, 5 centimeters a year, right? Now, what does this represent in an algebraic statement? I just gave you a big hint by calling this run and rise. What's rise over run again? What's your slope, right? So in an algebraic statement, 5 centimeters per year, that's going to be our slope. That's going to be our m value. Hold on to that for a second. That's really important. Here we go. Part B. So if X represents years since 1984, very careful with the wording there, years since 1984. So if the year was 1980, oh my God, not 18, I'm going to fix this up, 1985. If the year was 1985, then that means X is 1. If it was 1986, that would mean X is 2, and so on, right? So if X represents years since 1984 and Y represents height of the tree, use the provided information to find the value of B. Interesting. So you got to be careful on something like this. X is representing years since 1984. Well, we know 2017 and we also know 2022. Give you a hint, we don't need both of those. We'll just stick with 2017 for now. I'll show you what I mean. Think about it this way. 2017, how many years was that since 1984? Well, you can find that just by subtracting these two, right? So 2017 minus 1984, if you throw that in your calculator, you're going to see that's actually 33 years since 1984. Okay, so that was 13 years apart. So in this one, we can say X is 33 years. Now, Y in this case, when X is 33, Y was just straight up 550. Remember earlier when I said, okay, we have Y equals MX plus B. Remember earlier when I said, oh, you could find your M and then you could use that M as a skeleton equation to find B? Yeah, this is why we're calling it a tough example, because you're going to have to do that here. Here's what I mean. We know M from that last part of the question is 5. So we know we have Y equals 5X plus B. We want to figure out what the value of B is, right? To do that, let's just plug in a known X and a Y. Be careful, like I said before, X represents years since 1984. So since we knew 2017 was 33 years since 1984, we're going to say X is 33 and Y is 550. So Y is 550, and then that's 5 times 33 plus B. So first of all, I'm going to figure out what that 5 times 33 is, because that's kind of garbage, right? So 550 equals 5 times 33, which is 165, plus B, minus 165 from both sides, 550 minus 165. I'll even show this here, minus 165, minus 165, boom, boom. 550 minus 165, well, that's 385 equals B. There we are. Got what that value is right there. All right, so the next one, predict how tall the tree will be in year 2050. Before we get there, sorry to come back to this. Before we get there, I really should explain. What do you think the significance of this B value is here? Like, this actually has some pretty significant significance, you know, like there's actually something really important with this. Remember, we talked before about what B is visually on a graph. On a graph, B is like your y-intercept, right? That would be your B value. Now, if this is talking about the height of the tree since 1984, and we knew the tree was planted in 1984, well, B being our y-intercept, in other words, where X is 0 means the year 1984 in this context. So this B of 385, that's how tall that tree must have been when they planted it. And I mean, if this is an accurate question, I honestly don't think it is, but if that's an accurate question, holy smokes, that was a tall tree when they planted it. That'd be like, you know, if this is 575 or whatever, that's like to here. That's way bigger than the dumpster. My goodness, right? Like that'd be a huge tree to plant. But anyway, I really wanted to illustrate that B value is like your starting value. That's how tall that tree was back when it was planted. So kind of cool. Anyway, now we can move forward. Predict how tall the tree will be in the year 2050. So once again, let's write our equation. I'm not going to write y equals mx plus b. We know what our m is. M was 5. So y equals 5x plus, what was b again? It was 385. There we go. Sorry for flipping around all over the place here. 385. we have the year 2050. Remember, X represents years since 1984. So we need to figure out that first. I'm going to go 2050 minus 1984. Let me just plug that in real quick. Minus 1984. That's 66 years. So when this tree is 66 years old, we want to figure out how tall this tree is. So let's throw that in there. 66 is our X, right? So we got Y equals 5 times 66 plus 385. You can throw that right in your calculator. 5 times 66 plus 385. This gives me Y equals 715. And I guess Y is a height, so we should put that as centimeters. So 715 centimeters, that's how tall that tree will be in the distant future, 2050. All right, so that was a really long lesson today. I apologize. If you don't quite get to all the questions in the handout today, I wouldn't blame you, but the handout is there. Make sure you're completing all of them, whether you're doing that today or tomorrow. Remember, most of the classes we have for this, you'll have 2 blocks to do all this, so there's no rush. If you have any questions, though, please make sure you're reaching out and asking. Best of luck.